All right.
And welcome.
Yes, welcome everybody. Sorry for the technical difficulties that kept us from starting on time, but welcome to our open house workshop. So just to begin, my name is Jared Showers. I've been in the industry, the animation industry, for a little over 25 years now, and worked on many games throughout my career and have tried many different facets of game development, from the keyframe animation to the motion capture to cinematics and gameplay. And I'm also here with several friends of mine that are also industry veterans. We've got Evan Mead. He is lead animator at Mountaintop Games. Evan, would you like to say a few things?
Yeah, thanks for having me. Yeah, so I've worked on a bunch of different games over the past 15, 16 years. And yeah, I'm currently working on a tactical shooter at Mountaintop Games. And yeah, I'm super excited to start walking through some basic animation blueprint stuff today.
Yeah, thank you. Thanks for your help in all of this. And then we have Matt Hansen, who is our the backbone to our program here. He is helping out so much with just helping students get the technical help that they need and support, and also just an amazing human being. Thanks for being here, Matt. Would you mind saying a few things about yourself?
Yeah, of course. Hi, I'm Matt. I am an AnimSchool alumni. I graduated in 2021. And right out of school, I was able to get a job at High Moon Studios working on Call of Duty. Was there for a couple of years, and now I'm an animator over at Superseed.
Yay! All right. So I guess just to start, I want to give a little bit of a background on what we have to offer at AnimSchool as far as education goes. And then I'll hand it over to Evan, and he's going to talk a little bit about Unreal and how to demystify animation blueprints in Unreal. So from the beginning, we built the curriculum in our courses around our classes being set up like a real game job. And let me share my screen here so I have a little bit better things to show than myself. So, all right. So, I don't know if we're able to switch back and forth to shared screens or not. I'll keep talking for Kim. All right, great. So our program at AnimSchool starts around class 5. So students that come in and they know nothing about Maya, they may start at class 1 in the Intro to Maya class, and then they work their way through some body mechanic classes. And right after class 4, they get to make a decision about whether or not they want to head more towards the performance track that tends to lead to film and television, or if they want to take the games track. And there's certainly no order about this. You can go all the way through the performance track and then continue on and keep learning and going into the games track. Or you can take this class after having a good foundation of body mechanics. And the program also offers a way for folks to submit their reels, and then they can be placed by administration to find out exactly where they might fit. All right, well, in class 5, which I oftentimes call class 1, because that's really where our adventure in gaming begins. This is the introduction to video game class. This is one that is near and dear to my heart because I've taught it for 10 years. And it begins with the idea that we want to be able to service the player. We want to talk about player mechanics. We want to talk about game feel. We want to create movement that evokes character and emotion, all while you're playing the game. These are the things that I love about game development personally. is that immersiveness, being able to build that empathy between you and the avatar that you see on screen, just with the controller. You've got the physical buttons that can connect you. So we'll start off our program talking about poses and some of the fundamentals of game development. And students that come into this class, they don't need to know anything about games. They don't even have to really like them. I've had students that have come in and they really just wanted to get a better handle of body mechanics, which is something that we do focus on. And by the end, I've been able to, at least it's my hope, to convince them that games are a great avenue for a career. So we have 11 weeks in our classes, and the way that these courses are set up is that we work fairly quickly. 1 week per assignment usually. We'll go from an idle, we'll do a move animation, we'll do jumping, we'll do attacks, and then we will do one enemy attack. And that's so that we can create an entire game loop. We'll end with a death. That game loop is, what is the game about? What experience do we want to give the players? All right. Now, you might be asking, well, what game are we working on? Well, in Unreal, I've put together a game project for our animation students to use. And this is a place for you to come in and learn Unreal from scratch. We tend to just teach you the surface level basics to start. And then for those that are a little bit more ambitious or have more time, they will take this to another level. And the idea is that all of our assignments are scalable. So there's plenty to do, plenty to add your own style and personality into this game. Now, the game is called Golden Egg, and this harkens back to me growing up and playing, having birthday parties, playing Golden Axe in the arcades. And so I really wanted to just make a framework for students to be able to put their animations into the game and make it their own. This is not my game. This is the game that the students are able to take on their own. And the idea is that everything that they work on in all three of these classes can be added to this project. So by the end, it is yours. All right. And you're also taking out all the animations that are not yours, because this also works as a good demo reel piece. We really want students to come out of this program with as close to real world experience as possible. And we don't always just focus on the animation side of things. There's also a lot of technical things that we want to introduce to animators as well. For those of you that have animated in the gaming industry, you don't just sit behind a desk and animate in Maya all day. You tend to need to be able to take your animation and to iterate on it, to go back and forth with a programmer or an audio engineer, another department, and really take that animation that you've created across the finish line to work well with the rest of the game. This is a very team-based industry, so we do focus also in our classes on some of the soft skills involved in getting a job in the industry. Things like communication, especially these days when everybody has had the chance to work remotely. Since COVID hit, there's been a lot more remote jobs that are available, which is great, because that means that you don't have to move around when you need to get a new job. There is by the way, there is a map. If you go to gamedevmap.com, there's a map of the world, and there's little hyperlinks here for game studios that might be near you. Here's Oregon. you can see here. Certainly lots of studios are around the world. Maybe there's one near you. And also with remote being such a big, important part of our industry nowadays, there's certainly a lot more remote jobs that you can be open to. You don't have to move around for that. After we get through about week 9, actually week 8, through our assignments, then we will finish up by using our last 2 weeks for polish. That's where we go back to our animations, the first pass that we've done, the one that is in the game. And we begin polishing that. That is to simulate the idea that you've handed off your assets to another department and you're no longer blocking anybody. So then you get to go back and make that sing. We also spend time putting together a demo reel. And it's important that even by the end of this class that you have a demo reel that you can submit to other studios and begin applying. All right, I have here a video from some past work. This is, you might see a familiar name on there from our previous student reel here. And I'll just hit play. We can take a look at this here. You can see some of the work that has been coming out of this class. Yay, there's our Matt Hansen. Beautiful work. And what I love about this, I'm just going to call this out. He took what was possible to the next level by looking into things like animating materials, things like that. You can see on Riker's chest here, that material goes out. This is something that he was excited about learning, and he dove into that, and then even wrote up a tutorial on how others can do that as well. So we do have several characters in our pipeline that AnimSchool provides. We've got Riker, we've got the Demon Sorceress, we've got Firetail, who's a werewolf. All of our characters that we provide are available to use as either a player character or an enemy character. And we've also been pushing lately the idea of being able to customize these characters and adding attachments to them. Things like shields or helmets and armor, even birthday hats or forks if you want to make a child at a birthday party not wanting to get the best presents they can by interacting with their the party members. I don't know, making that up. The idea is that it's all open. We want this class to be as much a representation of who you are and really allow for you to be able to express yourself. So the idea of putting your work in the engine might scare some of you, but I promise we make it as easy as possible, although it's not without some technical challenges. But that is the fun of game development, is that sometimes making the game is like playing a game. But the idea is that you would start to learn that logic behind why is this not working, or why is this not looking the way that that I would like it to, and really just to push yourself as a game developer, not just a game animator, but a game developer. We want you to understand the reasons why you do the things that you are. All right, so this is just a lineup of some of the characters. We do also allow some other game-ready rigs. And what you saw in this project as well is you see this gray level here. This is actually some free content that Epic has released to the public. I can't legally give you all of the little plants and the bricks and treasure chests and all that stuff. I need to create for you just the grade level underneath of it, and then you can replace that. So by the end, it can look all pretty with the lights and everything, but what you get is just starting with just the gray blackout level. All right, moving along, we move into our class 6, which is a focus on quadruped and creature animation. We talk about enemy AI. We also have room at the end to start introducing motion capture, which is also a very sought after skill for many folks. Motion capture is a huge part of the industry right now because it allows you to create a lot of animations real quickly. It is a style. It is something that maybe a game maybe doesn't need if you're a game that is really honing in on that cartoony squash and stretch feel. But if you're a game like Call of Duty, that's going to be something that's just going to help you move things along much quicker. And so we provide our own motion capture that we've recorded for the class. And we go through concepts like stitching and heightening and cycling. All right. And then by the end, this is the exciting part and another soft skill that we teach, and that is the exercise of interviewing. So interviews can be a little daunting at times, and it is a muscle that is worth practicing. So what our instructors have done is they've reached out to their industry coworkers or friends and have they've come in and have given some mock interviews. And this is a great no fail zone for folks to just speak their minds and be themselves and learn to be present in that interview. And finally, we have our cinematics class where we have 2 assignments. We've got an interaction, and then we've got a cinematic. And again, all of these can be added to the game in Unreal. You can use the renderer. You can render out a movie file of that. And this is also just a good bridge between performance and video games. For some of you that really like that character emotion and longer animations and that polish level that a lot of films tend to get to, this is a great class to really kind of satisfy that and find out what it means to be a cinematic animator or a narrative animator. There are certainly very specified roles in the gaming industry that we try to touch on a little bit throughout the courses, from gameplay animators, cinematic, narrative animators. There's even some in-view animator jobs out there. That's a specialization that we also touch on. I've been a weapons animator for many years in my career. So something else I just wanted to mention here before I hand it over to Evan. And that is that this industry is very, very volatile. But you look at the revenue that games are making, and it's very high. All right. If I was just looking, it's like 184 billion that it made, and this is like up by like 6%, and that's usually generally about where it tends to grow every year. So we know the demand is there, but lately in the news, we have been seeing a lot of layoffs. All right. And for those of you watching that have been laid off already or have been affected by layoffs, my heart goes out to you because I have been laid off multiple times myself. I will just say that I hope that you realize that the place where you worked is not your identity, and that you are valuable. And when I was laid off, I really took that time to really learn something new, because I knew that was something that nobody could take away from me. I wanted to make myself more employable. I still had that passion. It was hard not being with the same folks that I used to. Change is hard. But in the end, folks, friends, who are very much like family. Sometimes they go off and get jobs, and then in turn that opens up new opportunities then for you to try something new and to grow. All right, I'm a lifelong learner. A lot of folks at AnimSchool, that is our mentality here, is that learning should never get old, and you should always stay open to what others have to say. And that is why we wanted to talk about this today. We wanted to have just a free workshop to hopefully you can come away with something new, a new mindset, a new workflow. I know even the way that we do animation blueprints in Unreal is different from studio to studio. So I'm excited to learn something new as well. And I'd like to now hand it over to Evan to talk about animation blueprints.
Thanks, Jared. All right, welcome everybody. Okay, so let's get started. So today we're going to create an animation blueprint from scratch and kind of go over just like basic locomotion and how you can set up some of that stuff in the event graph. But before we get started, I'm going to set up my preferences to be more like Maya. So I'm going to go to invert pan. I'm going to check that on. And orbit round selection. So with those two on now feels more like Maya to me. Now it's much more comfortable. Kind of depends on your own preference. But one other thing I'm going to do here is going to go and change. When I play the game, I'm going to put this to new editor window, and I'm going to change the advanced settings to let's see, always play on top. It's already checked, so should be good to go there. All right, so first I'm going to go here and create. Sorry, go ahead, Jared.
Real quick, Evan, if you don't mind. So would you mind just showing this, like where can folks find this project?
Oh yeah, I'm sorry. Yeah, so this is the default third-person project that's included with Unreal Engine. You should be able to just add this project like when you download the engine, and you'll have all this content. Like everything I'm using here is stuff that you can grab from that project.
Yeah, so
thanks
free
for
is good.
mentioning that. And this is Unreal 5.3 as well. Like,
okay.
This is, yeah, free is good. Free is nice. All right, so we're going to create an animation blueprint. And so one thing about animation blueprints is that they're specific to your skeleton. So animation blueprints are specialized blueprints inside of Unreal that are like, we use them to control our animation. So I'm going to pick my Manny character here that's included with the project. So if we wanted to like have a quadruped or something like that, that would not be able to share this animation blueprint because that would have a different skeletal hierarchy. So you'd have to go through like a process of retargeting to change those assets over and like copy them over. But we're not going to get into that today. We're going to keep this more simple. So let's call this animation blueprints. Okay. But before we can do anything else, first we need to go add this animation blueprint to our character. So this is the character that's included with the project, the BP third-person character. So I'm going to open this up, and then I'm going to point it to our new blueprint that we just created. I forgot what I called it. What did I call it? ABP demo. Okay. It's good to know the names of your assets. All right, there we go. And then I'm going to change the skeletal mesh asset here to a Manny simple to our many character. And then you notice, like, after I make these changes, that got this little question mark here, and that just means that I need to hit this compile, and then I should be good to go. And if you have any issues or errors, those will pop up down here. All right, so now we have our blueprints, character blueprint pointing to our animation blueprint. Let's check that out in game. All right.
And while you're showing that off, Evan, I'm just going to make a quick note because maybe there's some folks that don't know some of the terminology you're using, like a blueprint or animation blueprints and things like that. You know, I think that the important part about this, like as we watch Evan go through this, if you're not following along, is just to kind of understand like kind of the logic behind how you're hooking up animations to a game and to a character and more of like the logic behind it.
Yeah, exactly. Yeah. All right. So now we have here's our blank animation blueprint, and it's scary because it's all blank. Let's look at what makes up an animation blueprint real quick. So we got an event graph and an anim graph. So the event graph is basically for like setting up our logic, like our speed, our velocity, that kind of thing. And the anim graph is basically how we're going to set up the states of our animation, how that's going to flow. So since this is blank and scary, let's just get started. So I'm going to grab the, try to get pawn owner here, and I'm going to cast this to character. And I'm going to grab here to character movement. And this might seem like, oh, what is happening? Yeah, there's really only a couple of things I'm doing here. Sometimes I get in a weird state. If you hit compile, that should help. All right. And then I'm going to promote this character movement to a variable or right click on it. Okay, I'll just character movement. That name works for me. And then I'm going to create another node here called event blueprints initialize animation. Connect that this execution node, and then connect the other one, and hit compile, and it should be good to go here. So the difference between this event blueprint update animation node is that this is going to like run every frame. So that's going to tick every frame. And if you're like, what does that mean? That means basically that the game is going to basically process all the logic that we create on each frame. So the more efficient that we can make our blueprints, that means the faster it's going to run here. So we don't need this logic to run on every frame. We just want this to work once. But down here, we're going to have variables that we want running every frame. So let's start by grabbing our character movement. I'm going to drag off, and I'm going to get my velocity. If anyone has questions as we're going through this, make sure to, feel free to shout them out, and I can try to answer them as we go. And then from velocity, I'm going to get my vector length, x, y, and this is because I want my forward, back, left, right movement. I don't want my up and down movement. So this will be our ground velocity.
And sometimes just like knowing which nodes to use, sometimes it's not super clear. But what's nice about Unreal is that when you right click or you drag off of a node, it will filter out only what you can use technically with.
Yeah, there's this context sensitive box, which is on by default. If you turn it off, then you could do all kinds of crazy stuff and nothing, good luck getting stuff to work. But yeah, that's kind of like a little cheat sheet. Like, oh, you can't do that. If you don't see it there, you probably can't do it. So we'll connect our execute nodes here. Let's hit compile. All right. So how do we know if this is actually working? Well, there's a couple different ways. First, I'm going to create a print string node here. So connect the execute, and then I'm going to just drag this into the name here and hit compile. Let's see what happens.
I should also mention that blueprints are a visual way to see code. Like this is written on top of C++.
Don't tell animators that because they might get scared, but yeah.
So you are coding right now.
In a very crude way, I'm coding right now. Yeah.
I'm a very visual person myself, so I would much rather look at boxes than words. personally, so this is helpful.
Awesome. Yeah. And I also have videos for these demonstrations too. I know my play rate might not be great, but we'll give it a shot here. So now when I move around, you see these numbers. That's my ground speed variable there printing on the screen. So I can definitely see that it's working. And then another way that we can monitor this value is if I just right click on it, I can do watch value. Then once I hit play here, I just need to choose my animation blueprint right here, my specific one. Now when I move around, you can see that value updating as well. So that's super helpful. Okay, so we have our ground speed. That's enough for us to start working on our animation states in the anim graph portion. So yeah, I'll come over here to my anim graph. Remember, our event graph is where we're setting up our logic. So in my anim graph, I'm going to create state machine. And let's just call this locomotion state machine. Go ahead and connect that. And a nice little shortcut here is if you just grab two nodes, hit Q, get that nice and straight. Feels good that way. Then I'm gonna come in here, I'm gonna create two states. I'll create a state for my stand idle here, and then another state for my movement. Connect this, and then I'll just go ahead and connect these two states together. So right now, I just have empty states. Let's go into my idle. I'm just going to filter this. I know my character starts with the MM prefix. So I'll just go in here, grab my idle. I'll just drag it into the window, connect it. And then something that changed in Unreal 5 is in Unreal 4, it would be checked to loop animation by default. That's no longer the case. Now we need to go in here. And since I know my idle, I want it to loop continuously. So I'm just going to hit true for that loop animation. And I'll go back to my locomotion state. For now, I'm just going to grab this run animation, connect it, and then once again, hit that to be true. So it loops. Okay, so now we have two states, but we have nothing connecting them. So let's get our transition set up here. So to start with, I'll just get my ground speed, and I'll say if you're greater than, let's say, 0.2, if that's true, then you can enter this state. This 0.2 could be anything where you want, right? Like it's totally up to you. And then for the opposite transition, grab my ground speed once again, just get, I'm not do less than 2. If that's less than 2, then that means I'm transitioning back to my idle state. All right, so let's compile it and let's see if this worked. All right, so we're transitioning between states. We can see here, right? As we move, we go into our transition, or transitioning to our locomotion state. And as I stop, you're back to my idle state. But like, as I look at this, I'm seeing a couple issues. One is that his feet are kind of sliding around. And also that when you switch from states, it's kind of like flipping a switch, like a light switch or something, right? Like it's off or on, where when I'm moving in this game, I'm ramping up speed and then ramping down. So I'm missing all those values in between. So like the way that I'm going to deal with that right now is I'm going to try creating a blend space, because that way I can kind of get those in between values. So I'm going to escape out of here. I'm going to go back to my content drawer, to my folder here. I'm going to create a blend space. And so basically what I'm doing right here is creating a 1D blend space, but in Unreal 5, that's been moved to the legacy portion. So I'm just going to use a regular blend space because I'm not sure if legacy portions will eventually be phased out. So let's just create a regular blend space. Once again, we'll grab our Manny skeleton, call it PS demo for blend space. Okay, so inside the blend space, we have these two axes here. We have our horizontal axis and our vertical axis. So I'm going to call our horizontal axis speed. And then for now, I'll just make the maximum value 600. And I'm going to give it 2 divisions. And I'm not going to care about this vertical axis. So I'm just going to turn the divisions to 0. I'm just going to hide that. So next I need to add our animations here to this blend space. So first I'm going to grab this walk in place, and holding shift will snap it basically to this grid. So if I hold shift, drag it in, it's going to snap there. Then I'm going to select my walk, hold shift again, snap it over, and then I'll grab my run, snap it. So another really nice feature that's been added to Unreal 5 is this thing called this analysis right here, this analysis tool. So I'm going to take the horizontal axis function, and I want to analyze the velocity. And so for the axis, you see that our character is facing positive y. So let's switch that to positive y. Then our bone socket here, I want to use the root bone. So I have positive y roots, should be good to go. Let's hit this analyze all samples button. Stuff happened. Okay, so let's see what happens. So it's saying that our speed for the walk is 240, and our speed for the run is 532. Let's just say 532. So I'm going to change.
Hey, Evan,
Yeah.
is that analysis, is that the root motion?
Yes. So yeah, your character does need to be moving forward. So if I open up this run animation, say, oh, it's in place, but it's not. It's actually using this force root lock node. So if I uncheck that, you'll see that the character is running forward in space. So that gives it like the speed that we need to get these values in the blend space. So I gotta make sure to check this back on. Otherwise, you'll see like a ping-ponging effect when you see the character running through. Check that back on. And where did my blend space go? Okay, here's my run. All right, I'm going to go into my state here. And now that I have my blend space, I'll go ahead and drop it in. But notice there that the speed said 532. So let's check our speed in our BP character. Well, that's basically our max speed is set over here in the blueprint for the third-person character. So you can see here, walk speed, which is basically our movement speed, is set to 500. So it's never going to get to our max speed. So it's going to have feet sliding. So we can fix that by, let's see, what was that value? 532. So let's switch that to 532. By the way, units in Unreal are centimeters. Hit compile. Okay. And one other thing about these blend spaces, to see like the values as we ramp through them, you can just hold the control key and just like move with your mouse, and you'll see like, okay, this is what happens when I build up my speed. You're gonna travel through this axis. So let's go ahead and hook this up. Like I said, we don't need that vertical axis. I'm not concerned about that. So I'm just going to turn the expose pin off for that. Then I'll grab my ground speed here. I'm going to connect it. And then let's connect this state. And let's see what happens. So that's definitely much better. We're not kind of just sliding straight into the run. You can see we're ramping up a bit. And I'm just using the keyboard here. If I had my gamepad controller, then like, you could use the pressure from the thumbstick to walk if you like have less pressure. So that would all work here. And then you can also see, look at this node right here. As I move, you see that little X. You can see it traveling through the blend space real time. So I can see like as I travel, like as I get to my full speed, how it ramps up and down right in there. Awesome. All right. Well, there's still more that we can do here to make this look better. But first, let's talk about optimization again. So we want our animation to run as fast as it possibly can, right? We want it to be optimized so we get the best frame rate possible, and so engineering isn't upset with us. So let's go to our class settings here. There's this little checkbox about warn about blueprint usage. Let's check that on, see what happens. Okay, so it's not happy. There's something wrong. It's because we are, see, it highlights these two transitions right here. So what we're doing here is we're trying to do some logic here in the anim graph, and it doesn't like that. It wants simple like transitions, like true, false. So let's go back. Oops, I'm sorry. Let's go back to our anim graph. And I also know that in Unreal, in 5 that they've enabled this option here to make things thread safe. And thread safe basically is just optimizing it and making it so it can run like multiple things at once, and it should make our animation more efficient and faster. So I'm going to create a new function over here. I'm basically going to move my velocity into like a thread safe function. So I hit this plus, I'll just call this velocity function. And then you see over here in the details, there's this little thing that said thread safe. So I'm going to make sure I check that on. And then inside this function, I'm going to create something called a property access node. And then I'm basically going to recreate the logic I made before. So I got try get pawn over. And then I need to get my movement. And then I want my velocity down here. And then I'm going to take this, and again, I'm going to promote this to a variable, and let's call it velocity. And hit compile. So far, so good, although it's, there's something else we need to do first as well, is there's this little note here that says blueprint thread safe updated animation. So let's create one of those. And then we just need to drag this velocity function over and then connect it. And now this velocity value should be thread safe. So now let's go back to our event graph again. And now we can just grab this value, this velocity value, and I'll just get my velocity here. And I'm just gonna connect it here. Now I should no longer need that anymore. So now we're using this thread safe velocity. But then we also want a bool, because we want something that we can use in the anim graph, something simple for changing through states, transitioning states. So I'm going to say if this ground speed is greater than 0, let's make a bool and just call it B is moving. One word, and then you see like Unreal makes it look all nice right there. So let's connect that and then go back to our state machine here. Delete that old node. Okay, so let's go back into our transition here. And now let's use is moving. Connect that. And let's see what happens when I hit compile. Well, now we have good news. We have a lightning bolts. Lightning bolts are cool. So yeah, why are they though? Now that means it's fast path enabled. So fast path enabled is basically the most efficient way you can have your transitions going from state to state. So going forward, we want to make sure that every one of our states has this lightning bolt. So that way we know we are getting our max efficiency. You see it's no longer complaining about that connection now. So then I'm just going to go get my moving. Am I moving? Not. Hilarious. And then let's connect that. Delete this old thing. And let's check to make sure that this is working. So I'm moving. So now I transition to my locomotion state. And once I stop, you can see going back. And now I'm using my thread safe velocity. So it's much more optimized. And there's actually one more thing we can do to even make this feel a little better. There's something called blend profiles. So the third person project already has one made here called Fast Feet. So let's look at our character skeleton really quick. So if I open up the skeleton, I can go to my blend profile here and let me select Fast Feet. So now you can see these numbers. basically what that's saying is the lower the number, the faster it's going to blend. So if you look at the legs and the IK feet, they're set to 0.5, where everything else is set to 1. So that means like our feet and our legs should come to a stop or transition first. So let's take a look at that in action. One other thing I would want to do here is I don't want my blend time to be so high. So I'm going to change my blend in to my locomotion to something small like 0.5 or 0.05. Let's take a look at that. So the transition to the stop is not great, but it definitely like feels better as I'm transitioning into the locomotion now. And we can always go through and continue to dial these values. And you can also do this while the game is running. So we can just grab this value, make it something. Now it should look like it's popping horribly when we stop. Let's see. Yep, you can see that pop. So let's change that to something like 0.25. So yeah, you could spend all day tuning those values, and that's definitely part of the job. But there's still one more thing we can do here to make this look even better with just our locomotion. So I'm going to go into this antigraph in here. I'm going to create a control rig node, and then connect it here. And then once I hit compile, you can see I'm getting an error there. That's good. I need to select my control node, and I'm going to scroll down here. And then for control rig class, I'm going to pick basic foot IK. And then there's this little pin here. I'll turn that on, and then I'll check it on by default. Now let's check it out in game, see how this looks. So now when I get next to this ledge, you see it's shooting down like a trace, and it's putting the leg up where that collision is there, which is pretty cool.
I love that you can get a lot of things automatically.
Yeah.
Unreal. And I wonder if, because I usually, when I've taught about animation blueprints in Unreal 4, I've kind of dove into like how the animation blueprint is like the animator's playground. That they can go in, they can add lots of different transitions they want, they can fill it out. But I can see also what's nice is that even with a bare minimum number of animations, Unreal can take it and create transitions for you. Now, I will say it is a little choppy on our side, but I believe you.
After this, I'll share some videos to show some better examples. That might be easier just to wait till to the end to do that. But and yeah, if anyone has questions as we're going again, please feel free. So next, let's add an in-air component here. Like we have our ground locomotion. Let's add our character, what they would do in air. And I already know that I can grab this is falling function and create it to be thread safe. So let's just skip to that. So I'm going to create another function. I'm going to call this is falling function. And then again, make sure you check on thread safe. And then you're going to create, once again, this thing called a property access node. Then we'll get our pawn owner, our movement components. And this time we're just going to grab is falling. And is falling really just means you're in the air, which kind of throws me a little bit because it says is falling. So I'm going to create this. I'm going to promote it to be a variable. But for my own sake, I'm just going to call this is in air. And let's connect that. And then we just need to add that to our blueprint thread safe animation, update animation. So I just drag it over here. And once I connect that, now it should get these values and it will be thread safe. right, so let's go back to the anim graph portion here. Now that we have our logic, we can go ahead and start creating our in-air state. So I'm gonna drag this off. I'm gonna create a cached pose. And that's basically just, now I have a node here which will just reference this logic. All this logic up here, I can just use to pull from this one node. I'm gonna call it locomotion cached. Then let's create another state machine. Connect that. And I'll call this in-air state machine. And one reason I'm labeling things like SM and B like that is to avoid any like name clashes. All right, so if we just go in here, let's create a state. And I'm just going to call this my cached locomotion state. And inside here, I'm just going to reference that cached animation. So I got locomotion cached. So basically with this setup, nothing would happen. But now let's set up our jump and in-air transitions. So I'm going to start with, let's create a jump, a fall loop, and a land. So we're going to enter from our locomotion to our jump. Oops. Yeah, go ahead and add this animation. So just slide it over. Do not want that to loop, so I'll leave it like it is. To our fall loop. Just conveniently enabled loop. And I do want this to loop, so let's check on loop. And then to our land. We do not want to loop. And then back here to our cache state. So for now, let's use this transition B is in air to drive our jump. And here I'm going to set this to an automatic rule based on, what does that say? Sequence, player, and state. So basically this will wait till the animation plays out in full before it transitions. And then if I'm on the ground, if I'm landing, I'm going to grab B is in air, and I'm going to say not. Grab my not Boolean. So if I'm not in the air, then I'm landing. And then from this state, let's automatically transition there. And let's see if it worked. All right. Awesome. It works, but I shrink down into nothing. To avoid. So let's see what that is. Let's see if let me grab this land animation here. Scroll down and I can see that it's actually set to a local space additive, which is good because that's what we want here. We want to be able to play this land additively. So if we go back to our animation blueprint, just to right click and grab apply additive. So I'll use this as our additive animation. And then for the base, I'm going to get that cached locomotion pose. So whatever I'm doing, if I'm standing, if I'm running, that will be the base pose. So now let's give that a shot. So now we're working, and you can see as I run, it's playing that additively, that jump land additively on top of the run, which looks nice. But you can see there's this little hitch. Well, hopefully you can see that there's a little hitch as I hit the ground. And that's because if we go back in here, I have this set to play my whole jump animation before I hit the loop there, before I hit the ground. So what if I've fallen off and the distance is not very long, but it's playing this whole animation, right? Then it's going to basically play it, and then I'm gonna hit the ground and it's still playing the animation, and then I'll transition. So I want to be able to exit out of that immediately if I hit the ground. So I'm going to go to this this transition, this not in air. I'm going to promote this to shared. I'm just call it not in air. And so I can just add another transition rule here. You can add more than one. And in here, I'm just going to use my shared not in air. And I also know that, so now it should be landing a bit better, but I can get into my jump state again while I'm landing, right? And it's give me pretty bad results there. So I want to add here a transition from the land to the jump. So I'll just create another transition here. And let's just say, are you in air? Compile that. So now we have two options here. We can land, and if we don't move, it'll play out the animation to its full extent. Or if we start jumping again, it's going to transition immediately to the jump state. Let's check that out. So if I hit jump, I immediately jump again. So now I'm not jumping as a statue. Although I did get in a bad state there, and I think that's because I have too much blend time on my jump enter. So I'm just going to change this to something super short, 0.05. And you can also just promote your blend time durations as well. So I could go here and say, are you in air? And then I can use this shared blend time. So yeah, that feels a lot better. And we can also actually, let's use our blend profile, our fast feet profile on the land here. So our legs, so we don't have slidey legs when we're landing. So use our fast feet in both of these transitions. And since the jump transition is so short, I'm not going to worry about that one for now. Say compile. Let's also notice something else. Now that I've got my jump transitions working, when I walk off a ledge, I jump. But what if I don't want my character to jump when I walk off a ledge? What if I want them just to fall? Well, we currently don't have any way to deal with that with our logic, but it's relatively easy for us to set that up. So we're going to go back to the event graph now. And then I'm going to grab my velocity. And I want my up and down velocity, just my velocity, where if you look here, you see Z is up. So I'm going to right click here and I'm going to split struct pin. And I'm going to grab this Z velocity. And I know that if you watch this value, you'll see that when I jump, when you're going up, the velocity is positive. And then once you start to fall down, that velocity turns negative. So let's give it this logic that if it's greater than 0, so we know we're jumping up. Let's add one more check here. I'm going to create an add node. And you're in the air. So if your velocity is greater than 0, you're going up and you're in the air. Let's create a variable and a bool variable, and let's call it B is jumping. And at the same time, if you're less than 0, and you're in the air, we know that you're falling because the velocity is negative. So let's make that B is falling. Now we just need to connect these execution pins. Then let's go back to our anim graph over here. Let's go into our in air state. I'm going to remove this in air. And I'm going to add is jumping. And then let's promote this to shared. Is jumping. And then let's create a new state here. We'll just call this state falling. So we can go from our cache state, go straight into falling. And then for our transition, we'll use is falling. And then after that, after this falling state, we would want to be able to enter the fall loop in case we run off like a cliff that's super high. We should be able to transition to this fall loop. So we'll say when this fall animation is over, let's just automatically transition to this looping fall. And then we also want to hit the ground. We want to enter our land state. So we'll just grab this shared, not in air. Now let's see what that gives us. Let's move our screen over. So let's see what happens when I walk off here. So you see I T-pose because I have no animation in that state, but it is hitting the is falling state, right? And then when I hit jump, I'm jumping. So it's doing exactly what I want to do. Now let's create this ridiculous height up here. So this will test like, are we jumping and falling, and are we falling into our loop? So first I'm going to jump. So jump. So now I'm guaranteed to transition from my jump into my fall loop for however long it takes until I hit the ground. And let's see if falling works. Right. So if I walk off, I enter my falling states, and then I transition into the ground. Right. I'm sorry. I land, or I either go into my fall loop. So you can see, even with just only a few functions here, we've been able to create a whole like jump sequence and ground locomotion sequence. One other thing we can do actually to improve this. So we have this should do IK trace, but we don't want to IK trace when you are in the air, right? So let's grab is in air and make sure that it's only true if you're not in air. Okay, so let's just make sure it still works. So if we go over here, it's working. So it's true when I'm not in air. And then, like I mentioned before, you could definitely go in here. We go in here and adjust our transition times. If you want, you probably want this to be much shorter on the transition to land. Let's promote this to shared so we don't have to type it a bunch. So now we have the ability to land. We're playing this additively, so we can be running around, jump, and it's still going to play our land animation. And we have IK feet that's we're going to touch the ground. And yeah, if we walk off a ledge, we're going to enter a fall state. And then if we jump, we will make sure we enter our jump state.
That's really awesome, Evan. And you said that you did have videos of this recorded?
Yes. Yes.
Okay. It is really choppy, so I'm glad that you're at least narrating what we should be seeing.
Yeah. Use your imagination, then we'll show you for real. Let me just, I'm gonna do something for fun real quick, and then we can check out these videos. So let's go back to our anim graph here.
And by the way, I know that there is some sort of an optimized video button. This is the very first time that any one of us have done this live stream on YouTube. So I think we're just we're looking for that optimized button, but I'm not exactly sure where it is yet.
Yeah, yours look pretty good. So maybe it's just my internet connection here. Could be. All right, so I'm gonna have fun here real quick. Let's do something for fun. Let's cache out this in air. Let's call it in air cached. And I'm gonna grab that cache pose here, connect it to my base pose, and then I will connect this to our control rig for our IK. So just move this stuff out of the way. And I'm just going to grab this fall loop animation. I'm going to make sure it's set to loop. I'm going to connect this to my blend pose. And then I'm going to go back into my character skeleton here. I'm just going to grab the right arm. And so if I right click, I can do copy selected bone names. And in here, I'm going to go to the layer setup and branch filters. I'm going to create an element here. Right click, expand all. Then I'll have it start at the clavicle R. Then if I hit compile, you can see that now I'm just running around with my right arm in my fall loop. So say maybe you wanted this to like hold a torch or something like that. This could be like a fast way to quickly like implement something or prototype something. And now you see like it plays on top of everything else. And
Yeah, I love that. I mean, the idea of game animations not necessarily needing to be bespoke and just like a full-bodied animation of a character running with a torch versus running with a weapon or nothing. You know, you can save a lot of memory that way by using parts of animations and layering them on top of the other.
Yeah, absolutely. And there's also one thing I want to mention too is there's this mesh space rotation blend. If I check that on, it'll kind of keep my arm like in the same position as I'm running around, kind of like a world space type of thing. If I had like a world space constraint. Okay, let's do one more fun thing before we watch these videos. And then now I'm going to transform, modify bone. What if we wanted to add big head mode? Here's a way you could do that. So create this transform, modify bone. And I'm going to modify my head bone. And then I'm going to go to scale and I'm going to go to add existing. I'm also going to add existing to my translation. So let's see if I add it to double the size. And we know my Z is up. So what if I just try 0.5? Let's hit compile. Nice. So now we have big head mode.
All for free.
All for free with just one node. You know, I could put this on my roots. I could put it different places, obviously, but yeah, it just shows you like some just super fast ways you can do to make some big changes to your characters.
Yeah, I love that Unreal has so many different things that you can add to your animations. Even just like retargeting, you can share a lot of animations between one character and another, even with different proportions, using things like in-game IK that will just get your feet on the right position or hands on the weapon. It's all exciting.
Absolutely.
Yeah,
as long as your hierarchy is the same, then you can basically share anything.
Yeah. Do you want to share your videos? And while that's happening, Matt, do you have a couple of queued up questions maybe you want to?
I do.
Yes. Thanks for doing that, by the way.
Of course. Sean asked earlier, how do you blend upper body animations to lower like body locomotion for like crouching, all that stuff? So when we're in the process of building these animation blueprints and all these state machines, what are some of the things that like we should be thinking about while we're wanting to blend, our upper body that's moving independently from whatever our legs are doing as we run around in game?
Yeah, there's some different ways to do that. So there's two ways to do that. We could kind of like this we used here. We could have a layered blend per bone, or maybe you just want to adjust like the torso when you're crouching down. But we'd also like, we didn't cover this, but there's this concept of animation montages. So if you did do like your attack or something like that, you can set up those to play when you're in different positions. Like say you have like a crouch state or a standing state, you can make sure that those slots will only play on your montage when you're in those states. But yeah, like creating like upper body, lower body, that would be done probably with a layered blend per node. So if we wanted, actually, let's just try that real quick. We'll see. Well, let's see. Dangerous to do this on the fly. So if I just grab my idle animation here. see if I make that my base pose. Now my locomotion, my blend pose, and then
Yeah,
let's-
you're not sharing anything right
Oh.
now. So
that would help. Thank you. Thanks for mentioning that. Okay, so let me go back to my skeleton. I'm just going to grab it at, say, a spinal one. So I'm just going to copy that selected bone name. Let's go back in here and then create a branch filter. Now let's see what happens when I run around. So now it's only playing on my upper body, which is hilarious. So if I switch these two, let's see if my have my connections backwards there. And I'm also going to turn this to, like I mentioned before, mesh space rotation blend. Yeah, so now, you could have different upper body poses. Say you have like different weapons. You could be holding a pistol and then you switch to a melee weapon or something like that. And so you're sharing like all the leg motion there, as long as you're on the ground state. But hopefully that just kind of gives you an idea of some things you could do. I wouldn't do it this way exactly.
yeah, that's great. What else, Matt? What else you got?
Banana. Sorry if I'm mispronouncing any names here. Was wondering if all of what we're doing here could also apply to first-person games as well.
Yes, definitely. Yeah, everything here can apply to first person.
Yeah,
Same
where the
basic.
camera is, right? So does this belong to the game animation pipeline or the advanced game animation course? So what you've seen here today is certainly a little bit more, I think, technical and advanced past what we would talk about in our class. We do talk about animation blueprints, and our instructors with their own experience can take things certain directions and have that autonomy to do that. But we do try to make the courses as accessible as possible, starting with all I want to do is export my animation and just get in the game and hit play. And then once they are comfortable with that, then we take them to the next level where we talk about like, okay, now we can start playing with blend times. Like this is not working right, or it doesn't look quite right. This is what we can do for the next stage. So Evan here, he's very well versed in the animation blueprint, even more than me, and so I've learned a lot today, by the way. And he teaches the intro to game course, so he will certainly take some of this and add it to his class. But I think the idea is that you understand fundamentally what functionality you can get out of the animation blueprint and the logic that is used to sort of get your brain into that game developer headspace of what you can do. You can tell here, just even by hearing Evan talking, you know it's all about optimization and efficiency. How can we get the highest frame rate from this? How can we share the most number of animations from this? And this just frees up more time to animate other things. When you don't have to animate 50 different runs with different hand poses, you can add transitions or additive layers, things like that.
Yeah, for sure. And basically, like in the intro class, you have kind of a template to start with, so you don't need to worry. Like you won't be building these from scratch. You kind of be building upon the existing framework.
Nice. Oh, well, this is a nice. It's a nice plug, unsolicited. Looks like we have an alumni leaving some chat. Thank you for that.
Also, I have some videos whenever we want to try starting to share these.
Yeah.
And I'm probably gonna
let's see the end
forget
result.
which ones I already put. So we'll go. Let's go one at a time.
All right. Yeah.
Okay, so this one is showing like this is using the blend space. So you can see it like ramping up and down here, rather than just kind of flipping straight to a run state, right? You see a little bit of ramp up in speed and the feet kind of slowing down and taking a little step there.
Yeah, the foot sliding looks good. I mean, it's very minimal.
Yeah, so this is our jump, obviously. This is an example of an additive that's not set up correctly, right? So when you're debugging your work and you see stuff like that, if you see things exploding or shrinking, it's pretty much guaranteed to be an issue with an additive animation. And this is just showing like the full states of the jump. So you see it when we're running. Then we see obviously like the jump land is still playing as we're jumping, so we're not actually entering that state yet. So we fix that by adding the variable that if you're in air, you'll just immediately switch right to your jump animation. Let's add some more.
There is a question. For indie games, would you be expected to be able to build the blueprints and blend spaces?
It all really depends, right? Like at larger studios, you'll probably be a lot more specialized. So you probably would have tech artists and engineers, programmers, like kind of doing most of that work, and you're maybe focusing on content. Where smaller studios, you might be expected to carry like a bigger, do more things and set up your stuff in Unreal. It really kind of depends, to be honest. But I mean, one of the nice things is just learning some of this, right? Then you're able to maybe prototype ideas or kind of prove out your ideas and show someone without, waiting to bug an engineer or somebody for some of their time.
Yeah, I definitely wouldn't shy away from learning about animation blueprints as an animator. To be able to understand how your animation is going to be played means that you have more control over that end result. And if you are working at an indie studio, maybe your job doesn't require it, but I would certainly try to learn it and try to get in there so that you can help out. I think when there's fewer people, the more hats you wear, the better you can unblock yourself and others, and also just have more creative control.
Yeah, definitely.
Yeah, that's great. Any other?
I think there might be some other videos that we didn't get to if we want to just go through the remaining ones.
Okay.
I think we might have seen this one. Okay, so this one is fixing the issue where it was getting stuck in that jump land state. So now we fixed in this one. And then this is kind of just showing everything we just did kind of in context. So we're falling, we're running around, we're jumping, and it might have seemed like there was a lot of work to get this set up, but once you do it a couple times, it's really a lot of results for minimum effort.
Yeah,
there.
I'd imagine a lot of this learning is through repetition and just getting in that headspace of that.
Yeah, definitely.
Well, cool. All right. Any other questions? I think at this point we could open it up to more Q&A if there's interest there.
I do got one question from Jason. What are some of the difference between feature/TV animation versus game animation?
That's good. Evan, do you have any thoughts on that?
Yeah, I would say there's a lot. I would say that game animation is typically like very physical, like lots of physical motion, where maybe there's, depending on less, like there's so many departments in game animation as well. Like, you could be a cinematic animator, but typically like a gameplay animator is more like physicality and action mostly. And then you probably, the pace at which you're doing stuff, you're trying to get stuff in the game as fast as possible. You want to block out things, even if it's in a rough state, to like unblock other departments. And then the game is kind of all being built at once, where in film you might have like, okay, the rigging's done, now it moves to animation. The animation's done, now it moves to lighting. Where in games, it's kind of everything's getting stacked on at the same time. So there's different complexities on both sides.
If I can also add to that, also for game animation, you are making the pieces of the whole puzzle. Where like in film, you'll be given a shot and that will be your shot. In gameplay animation, everyone's just adding the different little pieces, and you have just a small part, but it creates a much larger sum. And the next question, can you explain what logic is inside a game engine?
Yeah, sure. Can we mind sharing Unreal again? Yeah, so when I talk about logic, I'm talking about like these variables inside our event graph. Am I not sharing my? Sorry, let me share my screen again.
Okay.
My fault. I thought I had it shared. Okay. Yeah, so when we talk about logic, we're talking about things like these this floats for velocity, our velocity when we're going up and down. Basically, like each tick, that stuff is getting evaluated. So as your speed changes every frame, it's like the game's checking, okay, what's my speed now? What's my speed now? So yeah, like the more we can do to optimize that, the less time the game has to spend on processing that, the faster our playback will be.
If I can add just at the very simplest level, programming as a whole or game logic, like that's, it's essentially just asking questions, like a lot of yes or no questions. Like, are you in the air or not? Well, okay, I have the answer to that. So then what do I do with that answer? And that's really kind of what the logic is answering.
Next question. How much of blueprint knowledge is expected for a junior gameplay animator?
That's a good question. I wouldn't expect much, to be honest. But I think that is one of those things that's like helpful to have on a resume, right? Like I think as someone like reviewing resumes, if I see that someone has knowledge in Unreal or experience with Unreal, like that's going to make me, I'm going to perk up at that.
Next question. To make gameplay animation in Unreal, do we need to know and do proper animations in Maya?
No, I mean, there's we're not getting into it here, but there's something in Unreal called the control rig now, where you can actually animate inside Unreal. And then, you could animate in Blender, you can animate any package. You basically just need, if you're doing it in a separate package, you need something that you can export an FBX from. And then as long as you have an FBX, you can import that into Unreal.
Yeah, and there's even, there's a lot of free options out there too. If the gate is that Maya subscription, you can certainly pick up Blender and learn that, work with that, or do it inside of Unreal. I think Unreal is sort of leaning in that direction of having all of your content be made inside of that engine.
Next question. How do you package up your logic / anim graphs to apply to different characters?
So let's define different characters. So if different character is like another bipedal character that has the same hierarchy, then we can share this because they probably share the same skeleton. So like if I wanted to go back into the blueprint here, and if I want to change my character mesh to, we also have our Quinn character, which is basically the female version of Manny. So I can switch it to Quinn, and now I should just be able to see this in game. So now she has obviously like the same hierarchy and everything. But if it was like, if we added a bunch of more spine bones, then that would break our hierarchy, basically. Anything that kind of gets in between the chain would force us to like use a different skeleton, and then we would have to retarget all those assets to like that new skeleton.
Cool. Awesome. Next question. Does that control rig node that you did for the IK feet, does that also work for any skeleton?
That's a good question. I think it would, but you would probably have to set this up to make sure, like, if your bones are labeled something different, that could be a problem. Let's see if we go into our anim
Yeah, I'm
graph.
sure you'd have to label it somehow, tag it as a foot bone.
Yeah.
Describe what the IK chain was for that leg.
Okay, so yeah, so it's got this whole graph, this whole setup here, and it's using, it's using bone names and stuff like that. So if your bone names match, then maybe it would work. But you might need to just like reference this and just replace, like, create one for your character, and then replace those bone names. It's super nice though, just be able to grab that and not only have IK on the feet, but have, traces, so it can like determine where your feet are supposed to be on like an incline.
Is cutscene knowledge an aspect of gameplay animation?
I should defer to Jared for the for that.
Yeah, I think that cutscene is a word that can mean many different things. It could mean that maybe your character still has limited control. Maybe you can like move your head around, your camera. But I think in this case here, maybe it's more about taking control away from the player and playing an animation. So is cutscene knowledge an aspect of gameplay animation? I would say yes. It is not something that we specifically spend a lot of time in the player intro class. But as a whole, it's important to know where you are coming from and where you're going to when you are playing a cutscene. That's how you can create a more immersive, seamless transition from gameplay into a cutscene and then back out of it. So understanding what could the player be doing here, I think, is an important part of creating a really good cutscene.
Next question. How do you transition to ragdoll physics for damage or death? I'm assuming that's going to be a more technically advanced question.
Yeah, that's a little tricky. Basically, you would, that might need some support from engineering, but you have this thing, and maybe Jared, you can say it even better than I can, but basically have a physics asset that you can simulate, and on death, you would basically just transition to this physics asset and ragdoll.
Yeah, in our game, we animate our deaths all the way with a full body animation. That's because that they're considered longer animations. Usually there's some body mechanics that are involved, maybe even a little bit of a performance in there. So it makes a really good animation test to put on your demo reel, which is why we animate that. With that said, a lot of video games do tend to use ragdoll and physics to simulate their deaths, and that's just so that it can accommodate a lot of different situations up against a wall or downstairs and things like that. Unreal has this really great previewer for their rigs. So when you open up a rig with the physics asset showing, you can simulate physics and you can watch them all clump to the ground, and you can grab arms and wiggle them around, and you can set up rotational constraints so that elbows can only bend on one axis, things like that. So there is a lot of setup that's involved. We don't do that and spend a lot of time talking about it, although it is an important part of the gaming industry, is ragdoll and physics.
Yeah, ragdoll's huge for immersion, right? Like when you see someone like falling off something high or hitting a wall, and that way also like it saves the animators from doing like 1,000 death animations, because you can never predict like every context.
Yeah, absolutely. Next question. What is gameplay animators' expected responsibilities other than animation in the gaming pipeline? I'm guessing outside of just animating, do we have other tasks?
I'd say a big one is like cross-functional communication. Like we're constantly in gameplay working with designers. You might need to talk to environment artists about like if you have like a cinematic in a certain level. But yeah, there's all these different departments, tech animation, VFX, that you're basically constantly, communicating with and collaborating with. It's, you're not just like in a silo by yourself. You're working with everyone in tandem.
Yeah, and even within the animation department, like, it is helpful to have more skills that you can use at your disposal. You're not always required to use them, but rigging is also a very good skill to understand. At least constraints are really helpful even inside of Maya, um, and maybe a little bit of modeling, or just knowing how materials can get plugged in. As far as expected responsibilities, I would say, let's say from a junior animator level, I would say the main responsibility would be to be able to take the direction from the lead or your manager, and being able to animate your character well, and then owning that so that you can iterate on it, getting that into the game, testing it out. Everything needs to be tested in the game. You can't just look at an animation inside of Maya and get it to look perfect and then expect it to look the same in the game. As you saw with Evan's demonstration, there's lots of different opportunities to share animations and blend things. So that is the scale that we test all of our animations at. So that would be a responsibility for an animator.
Awesome. Next question. Is rigging knowledge good to have as a gameplay animator? Good question.
Oh, shout out Bryce. Hey, Bryce. Yeah, like I think it's definitely good to have. It makes you kind of like makes you able to debug issues. Like maybe there's some issues with your rig. If you have a little bit of rigging knowledge, maybe you can say, oh yeah, I think maybe this thing is wrong with my rig. Or if another department is all super busy with other stuff, you can handle some basic rigging. But yeah, like I definitely think that is helpful, but not required.
Another good question. Can you explain why root motion would be used instead of treadmill animations?
Yeah, so you could make your animation a treadmill animation and a root motion animation too. So, like you could animate it in place, and then when you export it, have it set it up so it's moving at the correct speed. But it's helpful because, like you saw, like if you saw the example with the blend space, we can see like the speed of the character. Or if you just open up the animation, okay, on frame 30, I can see how fast the character is moving. So yeah, so that gives us like the direction and velocity of the character. I'm not sure about you, Jared, but like, yeah, most projects I've worked on, like we've exported the characters actually moving in space.
Yeah, I've experienced both in different studios. Sometimes it's useful, especially if it's like a keyframed animation where you actually can control the foot gates to actually match what gameplay has set in place for their speeds. Usually an animator will not get to say how fast a character can run. That's usually up to the game designer. And with motion capture, when you have an actor moving through space, you can't get them to move at exactly 600 meters per second, or it's just not going to happen. So having root motion and treadmill experiences is helpful. In our class, we do animate through in place for our runs, and that's just to teach students how to do that. How do you calculate what that foot gate should be? If an engineer comes to you and says, I need a walk at 150 units per second, we want our students to be able to know how to do that. But certainly Unreal can use both, as we've just seen here.
I will say too, like when you're in game, like realistic speed is like a snail. Like when you're playing a game, usually it's like the speed that the design wants is going to be so fast that no human could probably move that quickly. But then when you play it, it feels good. So that's all that matters.
Next question. Does parenting props fall within the logic / anim state machine? that is transferring parenting from sheath to hand when switching weapons, etc.
Jared, I'm curious what you think here, but I would say that that's probably set in the blueprint, not the animation blueprint. You might have like different logic for different weapons in the animation blueprint, but like sheathing weapons and stuff like that would probably be set in the blueprint.
Yeah, I would agree with that. And I'll also add there are two different types of what we call meshes inside of Unreal. There's this static mesh that has no bones, and that can simply be attached to objects in the game, like bones and things like that. And then there are things called skeletal meshes, and they are skinned to joints that can move and are animated. And when you have an animated object, like an in-view weapon, for example, where you've got your player hands, but then the weapon itself might have joints on it that animate, that's when you would incorporate another animation state machine or animation blueprint. So you'd be playing those together so that those would sync up.
Cool. Next question. I'm currently learning animation and looking forward to working in the game industry. And but how is it? I'm sorry.
I think this is a similar one, like
Yeah,
workflow difference between
workflow
feature
difference.
and
Yeah,
game.
yeah.
Yeah, and in feature, you don't have to worry about having a game ready rig. In Unreal, you have to have a hierarchy of joints, and you can still use blend shapes and things like that. But really, in film, you can certainly incorporate things like lattices and ways to help you animate better outside of that control rig.
Same person looking for from a beginner or entry animator POV, and I start or get opportunity to work in feature. And if I feel to switch to gameplay animation, what difference? Well, I'm guessing like what are like the main differences between again working in film and
maybe
yeah,
even this applies a little bit to how you present yourself when you are applying to some of these other studios. If you're applying to a game job and you've only got performance shots on your reel, that doesn't really speak a lot to you as far as like how you're thinking about the player experience. I think that's really important to showcase on a demo reel that you're using to apply for a gameplay animator position. We really want to see how are you taking into account the player's experience as far as like response time and posing and just how can you showcase character in smaller sequences like your idle or running and walking, things like that. So I think in general, whatever position you're applying for, you want to make it very clear that you have experience or interest in that position. So whether that means moving some shots around or taking some shots off, that would be helpful.
Yeah, I guess kind of jumping off that, what are some of the differences between character and or game animation that maybe people should be kind of keeping in mind when they're either looking to switch to games or they're looking to apply to gameplay positions?
Well, I mean, I can speak real quick, and then maybe Evan's got some thoughts. But even just looking at reels and doing interviews and things like that, the things that I look for are just character. How do you show a character through a walk or a run? I really want to see an animation represented in a way that can only really be used for that character. We don't really want to see a lot of vanilla runs, things like that. But maybe there's something about this personality that you can really draw out. Doing a character analysis of your of the character you're animating. I want to see, your posing, really strong posing. through action. Good body mechanics, of course, good use of weight and force, I think is really helpful. Even more so than like performance, I would say. Just if you're looking for a gameplay animator position. If you're looking for cinematics, then you would for sure want more performance on there.
I would add real quick to that too, kind of like you went over, like the timing and the game feel is super important on the gameplay side. So, something that's might not look good in Maya, or maybe you have like some kind of insane speed, you have to try to make that work, because the on the gameplay side, gameplay is king. That's what we want to be the most important. So having things be responsive and feel good.
Next question. Does Unreal have any animpose matrix node, aim up, down, left, right, or would you have to set that up yourself?
It has an asset kind of similar to the blend space that we went over called an aim offset. And it is kind of similar. It is almost the same process where you have to select your skeleton and you create the assets. And then you have like different poses for your blends, but you need to have variables to drive them, like looking up, down, left, right. But yeah, it's I don't believe there's like any kind of out of the box solution other than maybe some kind of procedural setup. But how I've done in the past is by basically using aim poses for like 45 degrees on different directions.
Just for Matt, maybe we'll wrap up here with just a couple more questions here so we can be respectful of everybody's time and finish up before the end of the hour.
Of course. Next question. How many gameplay animations with implementation in the game engine 2 are the normal quota per week in most game development studios?
That's a great question. I think that the needs can vary depending on what sprint we sometimes call it. Sprint is usually like a 2-week time period where we focus on a specific part of the game that we want everybody to kind of rally around. If it's movement for a specific character, there might be a list, an animation list that you would work out with an engineer and try to figure out what can you do. I think that is important, is that any animator coming into the industry should have a good relationship with their lead and be able to talk about how they manage their own time and their own estimates. If a lead says, we need 50 animations, and then just hands it off to you, that doesn't open up that conversation of like, well, I can't do that. Or, you got the quality coming way down, then, let's understand what the trade-offs are for those. I did also mention that the way that we set up our curriculum is that we're sometimes moving very fast with one assignment per week. And then by the end, we have a couple of weeks set aside just for going back and polishing those animations. And again, that's just because sometimes the timing of when you start an animation and finish may vary. So as far as like having a quota, I wouldn't say that there's necessarily like a specific expected rate, but certainly you would want to have an open conversation with your lead about what you can accomplish in that time. Evan, did you have anything you would want to add to that?
Yeah, like I would say it's definitely not like TV where you might have like a quota for seconds each week. It's really depends. It just kind of depends on what you're working on. If you have this giant shot, no one's going to expect like you to finish, on a kind of, it really depends like per assignment. And I think like Jared said, we typically use like sprints to kind of estimate our time. So, as you're estimating time, you're trying to get like as close as realistic as possible. So I think like if you're saying, I need like 4 weeks for an idol, like that would, shoot off some red flags. But, it's at that same time, like no one can really perfectly estimate how long it's going to take to do something with all the different variables. But Yeah, so I guess it's not a great answer. Basically, kind of depends.
Yeah, and the speed will come with your experience too. So when you're first starting out as a junior, there's the expectation that things might be a little bit slower. You're learning the pipeline. You're figuring out how to interact with everybody and understanding the culture of the studio and things like that. So there's definitely some leeway there for timings. All right, one more.
Yeah. Sebastian writes, hello, I'm a freshman in college and I'm currently taking my programming classes and I'm interested in learning Unreal Engine. Anything I should learn before getting into Unreal?
I was trying to. I have a book back there. I'm trying to see it. I can't see it, of course. But there's, yeah, like I would, check Amazon. I think there's some great books for kind of like the programming Unreal portion. Like if you're learning programming, I would try to learn C++, since I think that's the native code side, as well as just like the fundamentals, right, of programming. Yeah, there's like so many resources online. Unreal has so many, or I'm sorry, Epic has so many resources and learning material that, yeah, there's just like you'll never run out of good material to learn Unreal.
I will say that I knew almost next to nothing before I built the game for our class, and I literally just went to YouTube and was like, okay, I want to have this function. I want to do this, and it was just kind of piecing it together. So yeah, I'm certainly not going to have any of those lightning bolts that Evan was showing us in his event graph, but it's still it taught me a lot just going to YouTube and learning a little bit at a time to finally things start to click. You're like, oh, I remember I set up this variable here, and now I can do my own variable, things like that. So yeah, I think YouTube is very good. I think that there's a great community there just for teaching. I want to thank Matt and Evan and everybody else that helped participate to make this happen today. Obviously, this is an open to the public thing, and we understand not everybody is here to jump into AnimSchool, but we do want to offer this promo code Game Start for those students that are interested in continuing to learn about game development. They want to get a good sense of every facet of that industry. And yeah, I look forward to hearing any feedback that you might have for us. You can look us up on LinkedIn, or I don't know if you guys have any places you want to plug at all, Evan or Matt, places to reach you.
Yeah, you can find me on LinkedIn, and kind of echo what Jared said. I would love to hear if this was useful, or if it was too in the weeds, or yeah, any kind of comments you might have would be great to hear. Thanks.
Yeah, it is a great industry to be in. The animators in there, we rally to help each other out. We share knowledge. That is our hope here as well, that you came away learning something. I know I did. I'm definitely going to rewatch this too. Follow along. But yeah, thank you everybody that took your morning out to watch us. I know it was early on the West Coast there, and but yeah, I look forward to hearing back from the community, and hope you guys all have a great rest of your weekend.
Thank you all.
Bye, guys.
Bye.